Hello everyone, Mr. Cruze here with a geometry lesson for you. This time, we're going to start off with Chapter 7. Chapter 7 is about similarity, something which is very similar, to what we've done before, which is congruence. And you'll see that as we go along, but to start off Chapter 7, we use a lot of things called ratios in this chapter. And there will be a lot of proportions that we'll have to solve. So it's good that our book takes this section out and specifically talks about ratios and proportions, okay? The sub should have given you notes, and I hope you're being good for the sub. They should have given you these notes so you can follow along with them as I go through them in the video, okay? And then you'll have an assignment to complete when you are done, okay? And the assignment is due tomorrow. I'll collect it when I get back. And as always, if you have questions, I'll be able to answer them then. Okay? Hopefully this video will help though. So, what is a ratio? Well, a ratio is a comparison of two numbers, call them A and B. And you'll notice I mentioned non-zero number, and the reason we has to be non-zero is because we're comparing them using division. And hopefully you know by now in your math journey that dividing by zero is a no-no. Lots of people will die if you try to divide by zero. Okay? So you're basically comparing two numbers using division. That sounds a lot like a fraction. Ratios can be written in three different ways. One is as a fraction, a over b. Another is with a colon b. Those mean the same thing. Okay. Those of you into like modeling and things like that, you might have seen ratios of like 1 to 100, things like that. Those are all ratios. And of course you can just write it out. A to B, it's just a comparison of A to B, 1 to 100, right? Or whatever. We're going to write ratios in simplest form, okay? So go by those old rules that all your previous teachers ever told you. Reduce any fractions. However, there's a huge issue here. When you're reducing ratios, the numerator and the denominator must be in the same units, okay? Circle this, star this, highlight it, something. Whoa. Why is my highlighter all the way down there? That's unusual. Circle, star it, highlight it, something. But that is huge. The numerator and the denominator must be in the same units. If you really want to know, the commonly missed thing from this section, the most commonly missed thing from this section, year after year, is people never put the numerator and the denominator in the same units. You have to, otherwise this will fall apart. Okay? So let's try some. Simplify the following ratios. 5 centimeters to 35 centimeters. First thing I notice, they're both in centimeters. They are in the same units. Okay? Once they're in the same units, you can basically reduce it like you would a fraction. 5 centimeters over 35 centimeters. One thing you might notice, the units will cancel. If they're the same, they'll cancel. They'll go away. So you really don't need units in your ratios, but they must be the same, otherwise they won't cancel like that. And how does 5 over 35 reduce? Well, they both divide by 5. Please be careful with this. Anyway, you get 1 over 7, which I would say since the original problem used colon, I would use a colon too, but you really don't have to. I would accept 1 over 7 as well. Okay? Take a look at the next one, 2 feet to 8 inches. I can't tell you how many times I have people do this. They put 1 to 4, which is wrong. I can't tell you how many X's I can draw through that. Okay? First thing, they're not even in the same units. One is a foot, the other's an inch. If those two are the same, then I am really like 200 feet tall. Okay? They are not the same units. So how do I get them into the same units? It's always easier to get the larger unit into the smaller unit. Okay? It's a lot harder to get a smaller unit to be a bigger unit. So in this case, feet are bigger than inches. So it's much easier to convert feet to inches. Well, how many inches are in a foot? And this is another part people have a little difficulty with. There are 12 inches in a foot. So I'm going to multiply by 12 inches. Right? So that means there are 24 inches in 2 feet. Hopefully a lot of you knew that already, but just in case you didn't. Hey look, now they're in the same units. So the units will go away. And then 24 over 8 reduces to 3 over 1. Now, please leave it 3 over 1. This is a ratio we're asking about. So do not just put 3. Okay, we're trying to compare two numbers, 3 over 1, and if you just put 3, then you just have one number. So make sure you do leave it over 1. Notice how that's a lot different than 1 to 4, as was originally suggested by a lot of students. Okay, please be careful. I kid you not, that is the number one biggest mistake people will make on this. Do not forget to change the units. There's a couple of odd, obscure unit conversions that you might come across in the homework involving meters and centimeters. If you get stuck on that, you can always ask me, or you can Google it. Google's a good, useful tool for that as well. Okay. They can also ask you questions like this. In the diagram, the length of AB to the length of BC is in the ratio 6 to 1. Basically what that means is, if AB were 6, BC would be 1, right? For every 6 units in AB, there's 1 unit in BC. Basically, it's 6 times as big, and you might be able to see that going on. But then they tell you, well, wait a minute, the whole thing, AC, is 21. 21 what? Inches, feet, doesn't matter. I want to find the actual length of AB and AC. This should say BC. My apologies, typo. Find the length of AB and the length of BC. Well, you might notice, if I currently leave it the way it is, 6 and 1, that would not add up to 21, right? So I need to figure out what multiple of 6 and 1 would add up to 21. If I double it or quadruple it or multiply it by 5, whatever, would those add up to 21? I could be here guessing that all day, so I'm going to make it a little easy for you. Anytime you come across a problem like this, put an X for each of these. 6x and 1x. I'm trying to figure out what number I need to multiply those by so that it adds up to 21. And then I can go back and I can actually say, well, hey, 6x plus 1x has to equal 21, right? And then there's a little algebra. 7x equals 21. That means x equals 3. I need to multiply both of those numbers by 3. So replace x with 3 in both of those, and you'll get the lengths. So AB is 6 times 3, which is 18, and BC is 1 times 3, which is 3. There's my answers. You'll notice both of them add up to 21, 18 plus 3, and you'll also notice that AB is 6 times as big as BC. As a matter of fact, if I were to reduce this ratio, 18 to 3, you'll see that it becomes 6 to 1, which is exactly what I said it'd be. Now this one, you might be wondering, well, Mr. Cruze, couldn't I have just noticed that they multiplied by 3? Well, sure, of course. But a lot of times it won't be just by that simple of a number. You'll have to do a little algebra to save yourself the work. So like I said, my trick is stick an x into both of these, or into this ratio, right? Because 6x and 1x would still reduce to 6 to 1, and then solve from there. Here's another example of that. The perimeter of a rectangle is 75 yards, so all the way around is 75. The ratio of the length to the width, and we'll go with length being the longer one, is 3 to 2. So that means this is 3 and 2. And hopefully we know from last chapter that a rectangle has opposite sides the same, right? Again, are they actually 3 and 2? Certainly not. 3 plus 2 plus 3 plus 2 is 10, right? Not 75. So that clearly doesn't work. However, if you put an X in for each of these, and then add them all up, which you should know from middle school or elementary school that perimeter is, and you set it equal to 75, which is what it's supposed to be, you can solve for x. See, algebra helps us out. So now, 3x and 2x twice is 10x equals 75. Divide by 10, and you get x equals 7.5, which means I need to plug 7.5 into both of these to get my length and my width. And you notice, you probably never would have guessed 7.5, right? You might have guessed 7 and 8 and things like that, but you never would have guessed 7.5. So algebra helps us out. So the length is 3 times 7.5, which should be 22.5. And the width is 2 times 7.5, which is 15. And a quick check, this is my width, this is my length. A quick check, you can check that. 37.5 and then twice is in fact 75 yards. Okay, and they did say yards, so we should probably put yards on these, just to be a little more clear. How about this one? The measures of two supplementary angles. That means they add up to 180 degrees, right? Are in the ratio 1 to 4. That means one angle is 4 times as big as the other. What are the measures of the angles? Again, stick an x in there because 1x to 4x still reduces to 1 to 4, right? The x's would cancel and all that good stuff. As long as x isn't 0, which of course it's not going to be. So, 1x and 4x, whatever those angles are, add up to 180. So that means 5x equals 180. And if you divide by 5, you get x equals 36. So, plug those into your two angles, and you'll get the actual angle measures. Well, 1 times 36 is 36 degrees, so that's that. 4 times 36 should be, 120 plus 24, so 144 degrees. You can check. Do they add up to 180? Sure. And is one of them 4 times as big as the other? You bet. Okay. Well, now that we've talked about ratios, an equation that sets two ratios equal is called a proportion. And it might look something like this. A over B equals C over D. They're two ratios, and they're just set equal. These numbers, the B and C, we call them the means. They're kind of in the middle, right? Means, middle, makes sense. They're kind of the balance point. The numbers A and D on the far outside, we call them the extremes, man. They're on the extreme far outside of the equation as we were to read it, right? A over B equals C over D. The A and the D are as far away from each other as possible. So you can solve this proportion by using what's known as the means extremes property. You know it as cross product or cross multiplication. Some of you know it as like the Hart method, right? Basically, if you have a proportion, you can cross multiply. So if A over B equals C over D, then that means A times D equals B times C. Basically, it gets rid of your fraction. It's very nice. I hope you know how to do this because this was part of your homework that you had to do for today. Okay, but we're going to be using this a lot. So anyway, solve the following proportions. As long as you see a proportion, cross multiply. So x times 16 equals 4 times 8. So that means 16x equals, well, 4 times 8 is what, 32? Finally divide by 16, and you end up with x equals 2. Good news with proportions, you can actually plug in the x and make sure that it reduces to the same thing. You can always check your answer this way. 2 over 4 is 1/2. 8 over 16 is also 1/2, so it checks out. A lot of people don't like to take time to check their work, but if you do, it's very nice. Also, you can cross multiply it to check it. 2 times 16 is 32, and 8 times 4 is 32. It checks out. Okay? How about 5 over 3 equals 15 over y? Again, cross multiply. So you get 5 times y equals 3 times 15, which happens to be 45, right? Divide by 5 and you get y equals 9. And once again, you can check this. 5 times 9 is 45, 3 times 15 is 45, so it works. This is a slightly tricky one. This is the only time it gets kind of tricky. You'll notice this time it's not just m, but now it's m plus 2. So we have to be a little careful when we cross multiply, because you have to remember your friend distribution property, right? Distributive property. This is the only tricky part. You have to make sure that 10 gets to both of these places. So it'll be 10m plus 20 equals, well, 5 times 14 is 70, and then solve from there. 10m equals 50, which means m equals 5. And again, you can always plug it in to check. 5 plus 2 is 7, right? 7 times 10 is 70, which is the same as 5 times 14. Okay? Well, that's it. I hope you've enjoyed it. The big thing I'm worried about are the ratios at the beginning. I feel confident you know how to solve proportions. But again, if you have any questions, please, 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 you can email me, cruze@gws.k12.in.us. I will have my phone and email available. Or you can tweet me, at Mr. Cruze Math, with any of your questions. If you need, I will try and respond as quickly as I can. Okay? Please be good for the sub. I wish you the best of luck working on your homework. You should be able to get it done with the remaining time in the period, okay? I will see you guys tomorrow. Have a fabulous afternoon.